Now we'll study the module 2, that is system drives and devices and actuators. Introduction to hydraulic and pneumatic actuators. In additive manufacturing, motion systems and components play a vital role. A additive manufacturing system comprises of many actuating devices such as electrical, hydraulic, pneumatic systems to fit any applications required. Now, hydraulic systems are used to control and transmit the power. A pump driven by a prime mover such as an electric motor creates a flow of fluid in which the pressure, direction and rate of flow are controlled by valves. An actuator is used to convert the energy of fluid back into the mechanical power. The amount of output power developed depends upon the flow rate, the pressure drop across the actuator and its overall efficiency. Thus, hydraulic actuators are devices used to convert pressure energy of the fluid into mechanical energy, depending upon the stage of actuation. Hydraulic actuators are classified like linear actuators and rotary actuators. For linear actuators, hydraulic cylinders extend and retract a piston rod to provide a push or pull force to drive the external load along a straight line path. For rotary, continuous angular movement is achieved by rotary actuators, more generally known as hydraulic motors. Now, in the hydraulic cylinders, the hydraulic cylinders convert the hydraulic power into the mechanical power, performing rectilinear motion. Cylinders are linear actuators that can push and pull, and when mounted around a joint, can actuate rotary motion. The pressure of input oil is converted into the force acting on the piston. The construction of hydraulic actuators is shown in a sketch. The construction of hydraulic and pneumatic linear actuators is similar. However, they differ at their operating pressure ranges. Typical pressure of hydraulic actuators is about 100 bar and a pneumatic system is around 10 bar. It consists of the piston, a piston rod, cylindrical valve, cylinder head and cylinder cap. The piston rod is extruded through the cylinder head. The piston carries a convenient sealing assembly to ensure the required internal tightness, while the cylinder head is equipped with convenient seals to resist external leakage. There are two types of the cylinders. First one is the single acting cylinders. A single acting cylinder can exert a force in only the extending direction as fluid from the pump enters the blank end of the cylinder. Hence, they named as single acting cylinders. Single acting cylinders do not retract hydraulically. The cylinders retract due to either gravitational force or assisted by spring. Now, the double acting cylinders, the main parts of the hydraulic double acting cylinders are piston rod, cylinder tube, and end caps. The figure shows double acting cylinders. The piston rod is connected to a piston head and other end extends out of the cylinder. The piston divides the cylinder into two chambers named the rod end side and piston end side. The seal prevent the leakage of oil between these two chambers. The cylindrical tube is fitted with end caps. The pressurized oil or air enters the cylinder chamber through the ports provided. In the rod end cover plate, a wiper seal is provided to prevent the leakage of oil and entry of contaminants into the cylinder. The combination of wiper seal, bearing, and sealing ring is called as cartridge assembly. Now, the end caps may be attached to the tube by threaded connection, welded connection, or tie rod connection. The piston seal prevents the metal to metal contact and wear of piston head and the tube. These seals are replaceable. End cushioning is also provided to prevent the compact with the end caps. Now the classification of hydraulic motors. Hydraulic motors are classified as gear motors, vane motors, and piston motors. Gear motors are the least efficient, most dirt tolerant, and have the lowest pressure rating. Piston motors are the most efficient, least dirt tolerant, have the high pressure rating. Vane motors and piston motors can be fixed or variable displacement, but gear motors are available with only the fixed displacements. Now, the gear motors are very similar in design to the gear pumps, but motors are usually designed to have a case drain port and a reversible direction of rotation. A gear motor develops torque due to hydraulic pressure acting against the area of one tooth. There are two teeth trying to move the rotor in the proper direction, while one net tooth at the center mesh tries to move it in the opposite direction. In the design of a gear motor, one of the gears is key to an output shaft, while the other is simply an idler gear. Pressurized oil is sent to the inlet port of the motor. Pressure is then applied to the gear teeth, causing the gears and output shaft to rotate. The pressure builds until enough torque is generated to rotate the output shaft against the load. The side load on the motor bearing is quite high because all the hydraulic pressure is on one side, limits the bearing life of the motor. Now, in the sketch, you can see gear motor. Most of the gear motors are bidirectional. Reversing the direction of flow can reverse the direction of rotation. As in case of the gear pumps, volumetric displacement is fixed due to high pressure at the inlet and low pressure at the outlet. A large side load on the shaft and the bearing is produced. Gear motors are normally limited to 150 bar operating pressures and 2500 RPM operating speed. They are available with a maximum flow capacity of 600 LPM. Now the vane motors. A rotary vane motor consists of circular chamber in which there is an electric or an eccentric rotor with sliding vanes in the slots provided on the rotor. The rotor is placed eccentrically with the housing. Fluid enters from the inlet port, rotates the rotor, and thus torque is produced. The displacement of a vane hydraulic motor is a function of eccentricity. The radial load on the shaft bearing of an unbalanced vane motor is also large because all its inlet pressure is on one side of the motor. Now the next one is balanced vane motor. As the figure shows, the balanced vane motor, there are various parts like high pressure fluid in, the opposing pressure ports, cancel sides, loads on shaft, low pressure fluid out, and the entire assembly could rotate. The radial bearing load problem is eliminated in this design by using a double load ring with diametrically opposite ports. Side force on side of the bearing is cancelled by an equal and opposite force from the diametrically opposite pressure of port. Like the like ports are generally connected internally so that only one inlet and outlet port are brought outside. The balanced vane type motor is reliable open loop control motor but has more internal leakage than piston type. Thank you.